Hey there, welcome to today's podcast. In the era of AI's rapid development, the infrastructure of AI computing power plays a crucial role. However, its utilization and load vary greatly, especially for those local intelligent computing facilities led by local governments or state-owned platforms. So, how can we enhance their enabling value? Today, we're honored to have an expert in this field with us. Our guest has in-depth knowledge and rich experience in the research and development of AI computing power infrastructure. Now, let's start our discussion. First question, could you briefly introduce the overall evolution trend of AI computing power infrastructure?
Sure. The evolution of AI computing power infrastructure mainly focuses on three aspects: technology innovation, layout optimization, and industrial upgrade. In terms of technology innovation, our country's AI computing power infrastructure is in a critical period of systemic upgrade and architecture evolution. It's developing towards an integrated form that is intensive, efficient, low, carbon, symbiotic, high, speed, and ubiquitous. For example, in the aspect of super large scale clustering, we've achieved breakthroughs. Super large scale clusters can support the training and complex reasoning tasks of large models with hundreds of billions or even trillions of parameters.
That sounds really interesting. Then, in the process of layout optimization, how does the coordinated development of national intelligent computing facilities come into play?
Well, policy guidance has been promoting the high quality development of intelligent computing centers. Since 2020, when the National Development and Reform Commission included intelligent computing centers in the new infrastructure category, relevant national departments have issued many documents. These policies have provided clear directions for the construction and layout of intelligent computing centers. At the same time, the construction of intelligent computing centers has been accelerating and the overall scale has been growing. For instance, by the end of June 2025, the total scale of in-use computing power center racks in our country reached 10.85 million standard racks, and the intelligent computing power scale reached 788 EFLOPS F16.
Amazing progress. How about the industrial upgrade? How does the coordinated development of the entire intelligent computing industry chain manifest?
The development of the intelligent computing power industry has been accelerating in terms of quality and speed. The Intelligent Computing Center, as a new type of infrastructure integrating computing power, storage power, and transportation power, has injected new momentum into the digital transformation of many industries. The upstream core hardware has seen accelerated domestic breakthroughs. The midstream computing power facility construction has been promoted on a large scale, and the downstream computing power applications have been penetrating into various industries. For example, the market share of domestic AI chips has increased from 15% in 2023 to 30% in 2024.
Great insights. Now let's talk about the important trends in the enabling of AI computing power infrastructure. First, how do the gradually clear demand scenarios promote the optimal allocation of intelligent computing resources?
Since the 14th five-year plan, the positioning of demand scenarios has become increasingly clear. Local governments and relevant entities are clarifying the boundaries between core service objects and investment and construction entities. They're also deepening their understanding of the pain points of intelligent transformation in local characteristic economies and the core businesses of central and state-owned enterprises, as well as the types of real computing power demands and application priorities. This has promoted a close combination of intelligent computing construction and industry applications, changing from promoting use through construction to driving construction through use. For example, some local governments have adjusted their investment and construction plans according to the actual computing power demands of local enterprises.
Understood. Then, how does the continuous strengthening of key capabilities improve the service level of intelligent computing center?
In the 14th five-year plan period, the service of AI computing power infrastructure has evolved rapidly towards a high level and full stack support system. In terms of basic support, intelligent computing centers are evolving from basic computing power resource supply to comprehensively supporting core capabilities, such as intelligent management of heterogeneous computing resources, efficient scheduling of large-scale clusters, high bandwidth and low latency network transmission, and high availability disaster tolerance systems. In innovation services, the support for cutting-edge AI frameworks, tool chains, development of industry, wide large models, and software, hardware collaborative innovation has been increasing. And in terms of operation guarantee, the operation guarantee system is becoming more and more complete, reversing the phenomenon of emphasizing construction while neglecting operation.
Makes sense. How does the integration of the landing ecosystem accelerate the release of the value of intelligent computing?
During the 14th five-year plan period, the construction of AI computing power infrastructure has been evolving from basic computing power supply to an integrated solution of computing power plus algorithm plus data plus scenario plus service. End quote. Sustainable and high value partner network has been initially established, and core entities such as independent software vendors, system integrators, key data suppliers, and algorithm research institutions are gathering. An effective ecological cooperation mechanism has been initially formed, which helps to reduce cooperation costs and enhance mutual trust among entities. For example, some regions have established industry-wide cooperation platforms to promote the integration of various elements.
Let's move on to the demand scenarios of AI computing power infrastructure. What are the main demand scenarios for large model computing?
The main demand scenarios for large model computing include training, fine-tuning, and reasoning. The scale of model parameters is proportional to the consumption of computing power. For the training of basic pre-trained large models with over hundreds of billions of parameters, high N10, 1000 card cluster centers with E-level EFLOPS computing power are required. For the training and fine-tuning of small models with hundreds of billions of parameters or less, or the reasoning of models, small and medium-sized intelligent computing centers with 100 P level 100 PFLOPS computing power can provide support.
Specifically, in the large model pre-training scenario, what kind of support is needed?
Large model training consumes a large amount of resources, mainly in the pre-training stage. It requires thousands to tens of thousands of GPUs for parallel operation, processing hundreds of billions to trillions of token data, and takes several weeks to months, accounting for 99% of the total computing power consumption. As the number of parameters in basic large models increases from hundreds of billions to trillions, the demand for underlying intelligent computing power in the pre-training process of large models has further increased. For example, OpenAI relied on 25 NVIDIA A100 GPUs to complete the pre-training of the GPT-4 model.
How about the large model fine-tuning scenario? What are the characteristics of this scenario?
Small-scale intelligent computing centers can effectively promote the fine-tuning training of industry models. Fine-tuning training of large models is a key link connecting pre-trained models with downstream application scenarios. 90% of the training scenarios are mainly concentrated on lone L2 large model fine-tuning. That is, the training and fine-tuning of industry models with less than hundreds of billions of parameters. Compared with the training of basic large models, the demand for intelligent computing resources in lone L2 large model fine-tuning has decreased exponentially. Local small-scale 100 P level intelligent computing centers have significant advantages in this regard. They can quickly integrate local computing resources to meet the model fine-tuning needs and reduce costs.
Understood. Then, in the large model reasoning scenario, what are the main demand characteristics?
In the current reasoning demand scenarios, cloud-side reasoning demand dominates. Different reasoning application scenarios have different requirements for reasoning models and intelligent computing centers. For example, in text dialogue and intelligent customer service scenarios with high real-time requirements, the latency requirement is generally within 50ms, and large language models such as GPT-3 or GLM can be used. For robot voice dialogue scenarios, the latency requirement is around 100 ms, and models like Llama can be used. And for non-real time interactive reasoning scenarios such as text to image and video, the latency can be 200 ms, and models like Stability can be used.
Now, let's talk about the key capabilities of AI computing power infrastructure. What is the core manifestation of the basic support capabilities of intelligent computing centers?
The basic support capabilities are the core manifestation of the basic technical capabilities of intelligent computing centers. For the training scene, it mainly focuses on cluster computing power effectiveness, cluster stability, the scale of a single cluster computing power, and the compatibility of mainstream computing frameworks. For the reasoning scene, it mainly focuses on token throughput rate, latency, and the heterogeneous diversity of intelligent computing cards. For example, in the training scene, reducing the computing power loss in multi-card and multi-machine interconnection can improve the cluster computing power effectiveness.
How about the innovation service capabilities? What kind of high-value technical services can intelligent computing centers provide?
The innovation service capabilities are the core manifestation of intelligent computing centers in promoting industrial innovation. For the training scene, it mainly focuses on the high efficiency of cloud services, the high efficiency of model migration, and the diversity of data governance. For the reasoning scene, it mainly focuses on the pooling and scheduling capabilities of intelligent computing resources and the high efficiency of model migration and deployment. For example, through cloud services, intelligent computing centers can provide users with more convenient and efficient computing power services.
And what about the operation guarantee capabilities? How do intelligent computing centers provide closed-loop business services?
The operation guarantee capabilities are the core manifestation of intelligent computing centers to achieve scientific operation. Both training and reasoning scenarios focus on the flexibility of computing power scheduling, the cost, effectiveness of computing power leasing, and security and compliance. In addition, the training scene also pays attention to the richness of cooperative entities that can be coordinated. For example, through an external computing power scheduling platform, intelligent computing centers can be flexibly scheduled to improve the utilization rate of computing resources.
Let's discuss the landing ecosystem of AI computing power infrastructure. Why is the synergy between intelligent computing and data elements so important?
The synergy between intelligent computing and data elements is crucial. Data provides the core resources for model training and reasoning in intelligent computing centers, and also serves as a key foundation for connecting multiple entities and gathering industrial forces. By cooperating with public data resource entities, general dataset construction institutions, and professional data governance units, intelligent computing centers can access multi-source data, improve the accuracy and diversity of services, and promote the transformation of high-quality data resources into intelligent computing ecological capabilities. For example, the Wenzhou Artificial Intelligence Computing Center has launched an innovative large model service based on trusted data space.
How about the synergy between intelligent computing and model algorithms? How does it help improve the innovation service capabilities of intelligent computing centers?
The synergy between intelligent computing and model algorithms is a key path to improve the innovation service capabilities of intelligent computing centers. By promoting the deep adaptation and optimization of computing power platforms and multiple model architectures, it can effectively connect the entire technical system from Dizi-Nian-Jian-Zhichen, core algorithm research and development, to upper layer application services. This computing power plus model integrated mode can provide end-to-end support for scientific research institutions and enterprises, accelerate the development and application iteration of vertical industry, specific models, and form a service ecosystem with complementary functions. For example, the Chongqing Artificial Intelligence Innovation Center has deeply adapted its Ascend Atlas series hardware to the DeepSeek Roan series models.
What about the synergy between intelligent computing and cross-domain intelligent computing? How does it help break through the bottlenecks of intelligent computing centers?
The synergy between intelligent computing and cross-domain intelligent computing is an important exploration for the leapfrog development of the operation capabilities of intelligent computing centers. With the acceleration of the iteration of AI technology and the ecosystem, the development of large models and related applications has put forward stronger and larger scale demands for intelligent computing power. To meet the training needs of large models with trillions of parameters or more, the interconnection between intelligent computing centers has become an important supplement. For example, China Unicom's Lingang Intelligent Computing Center has achieved a breakthrough in long-distance interconnection for distributed training.
How does the synergy between intelligent computing and industry scenarios drive the evolution and upgrading of the intelligent computing ecosystem?
The synergy between intelligent computing and industry scenarios is the core driving force for the continuous evolution and upgrading of the intelligent computing ecosystem. Major industry application scenarios such as autonomous driving and smart transportation not only provide continuous real demands and application verification environments for intelligent computing centers, but also promote their evolution from providing basic computing power services to a new service mode that is scenario adaptable, function specific, and performance evaluable. For example, the Chang'an Automobile Intelligent Computing Center, jointly built by Chang'an Automobile and Baidu Smart Cloud, has significantly accelerated the R&D process of intelligent networking and autonomous driving.
Finally, how does the synergy between intelligent computing and regional industries help intelligent computing centers achieve multi-dimensional and full scenario enabling?
The synergy between intelligent computing and regional industries is an important guarantee for intelligent computing centers to achieve multi-dimensional and full scenario enabling. By relying on computing power resources, it can attract enterprise agglomeration, promote cross-field cooperation, and jointly incubate solutions for multiple scenarios. It can also promote the deep integration of government, industry, academia, research, and application, forming an innovation closed loop and a good ecosystem. For example, the Wuhan Artificial Intelligence Computing Center has attracted many enterprises to settle in and jointly incubated numerous scenario-based solutions.
Well, today we've had an in-depth discussion with our guest about the AI computing power infrastructure, covering its evolution, demand scenarios, key capabilities, and landing ecosystem. We've learned that although there are still some challenges in the enabling process of AI computing power infrastructure, with the joint efforts of all parties, it will surely play a more important role in the digital economy. Thank you, guests, for sharing your valuable insights and experience with us. Also, thank you, listeners, for tuning in. See you next time.